Hello, I am Miriabili Tarkeswaro. I am pursuing BTech in Centurion University, Parlakendi. I have registered chip design and fabrication using VLSI as my domain. In my 5th semester, I have done a project on it. The name of the project is Design of Compressors and Fault Tolerant Application. I have learned about analog VLSI, digital VLSI and ASIC design in my VLSI domain. The project mainly emerged from the ASIC implementation through the ASIC flow and the ASIC design. The multiplier is done. And coming to the block diagram, first of all, I will give a brief description about multiplier. We know that multipliers are fundamental subsystems of microprocessors, digital signal processors. A multiplier includes a few blocks like partial product generation, partial product reduction, and carry propagate addition. For that, we have to know about some compressors. Mainly compressors are of two types. One is exact compressors, another one is approximate compressors. These approximate compressors are classified into different types of compressors like approximate 2/1 compressor, approximate 3/2 compressor, approximate 4/2 compressor, like so on. Coming to this diagram, this is the methodological diagram which is said how data is compressed and consume the power reduction error probability and get good efficiency using low power. It is need 3 steps to make an exact compressor. Every compressor need 2 types of number elements. It is called partial product generation. After generating the partial product, it's multiplied with the help of AND gate. These multiplication techniques called partial product reduction because it's reduce the memory space. After reduction process, we add the gain signals or components by the help of OR gate, half adder, full adder, and the every carry always add on the array wise and sum is giving in the final output either or it add in column wise until we will get the final product. These methods is called carry propagate addition. The entire block is called exact multiplier BCS. It's give a exact output without errors. Let's see the ASIC flow. Start the ASIC flow. Specification of the project, RTL coding, next functional simulation of each and every block, and next synthesis of processor. We need to see the timing reports and timing simulation where we have in the processor synthesis. Then we will go for the backend design where we start the backend design of floor planning and next power planning, next placement, CTS, routing, and next we check the design rule checkup, DRC versus LVS, layout versus schematic, and we will extract the RC and we will generate GDS file that is sent to the foundry for the final chip fabrication. The main objective is to design the exact multiplier and fabricate it from the generated GDS file. Implementation of approximate and exact multipliers. We have to import required files and libraries. After importing, we have to enter the commands. For opening the code editor, command for code editor is gedit. Here we have to write the main code for exact multiplier. After writing the code, we need to save as multiplier.verilog file. And here we have to write the text bench code for exact multiplier and we need to save as multiplier.test.v. Using NClaunch, we can compile, elaborate, simulate functional simulation. We need to check the functional simulation of the multiplier. For that, we need to enter the code nclaunch.new. Here, we need to include according to the steps. After that, first thing we need to compile all the individual blocks and check for errors. If no errors, we need to elaborate them. If still there are no errors, we can simulate them the test bench code. After that, it should be sent to waveform window to see the functional simulation in SimVision window. The waves represents the output signal of the exact multiplier. We use RTL compiler to generate RTL schematic. To open RTL compiler, we need to write the command rc space -frc underscore script 1.tcl -gui. The RTL schematic of register file is shown here. It determines the type of instructions and extract the operands. Here we can see the reports like timing reports, area reports, power reports, and here that is generated in the process of synthesis, and netlist file is also generated. Let's start the backend design. Here in the backend design, first floor plan, power plan. After several steps, the backend design is finished. Here we need to enter the command encounter. The encounter command opens. Here we need to import the design. In design import, we need to import the netlist file which is generated in synthesis. We need to specify the floor plan. Here we need to add the rings. We need to add power rings, that is VDD, power supply and ground, and we need to add the strips which are shown in this figure. In this image we takes place the routing. Routing takes the design time and a large percentage of the layout area. After seeing the timing reports and timing values without errors, we need to go for the further step placements and clock tree synthesis. After several steps, we have to complete the export GDS, and it is the file of the verified geometry. In this figure we have seen the final chip layout of the multiplier. For all the stages for logic synthesis, fabrication is considered as the backend design. We start with the logic synthesis like placement, routing, layout, physical verification and static timing, and finally we got the final chip layout of the multiplier. Coming to the image processing is a method that develops to convert the image into digital form and perform some operations to obtain specific models or to extract useful information from it. Here are some commands which are used in Jupyter Notebook for image processing, like commands like pip install numpy, pip install pandas, pip install matplotlib, pip install sklearn, pip install scipy. Here are the some of the images which are related to the image processing. This image shows the image obtained by the exact addition and approximate addition. And here is one of the image which is related to the exact subtraction and approx subtraction. Thank you.